Welcome back to the Tech Mechanic. Continuing our Solutions Architecture series, let's dive in. Imagine a user in United States watching Netflix, while another user in the India watches the same movie. If every request traveled to a single server located in one country, loading would be slow. Yet Netflix feels fast almost everywhere. How is that possible? The answer is a CDN, or Content Delivery Network. Today we'll learn how CDNs make applications faster and why architects almost always use them. Whenever data travels across the internet, distance matters. The farther a user is from the server, the longer requests take. This delay is called latency. If users from around the world access a single server, performance suffers. Architects look at this problem and ask, how can we bring content closer to users? A CDN is a network of servers distributed across multiple geographic locations. Instead of every user accessing the main server, users receive content from the nearest CDN location. This dramatically reduces latency and improves user experience. Imagine Amazon has only one warehouse in the world. Every package would take days or weeks to arrive. Instead, Amazon places warehouse close to customers. A CDN works in a similar way. Rather than delivering content from one central server, copies of content are stored in locations around the world. CDNs are typically used for static content. Examples include images, videos, JavaScript files, CSS files, PDFs, and product images. Since this content doesn't change frequently, it can be safely stored at edge locations and delivered quickly to users. When a user requests content, the CDN first checks whether it already has a copy. If the content exists, it's called a cache hit, and the CDN serves it immediately. If the content isn't available, it's called a cache miss. The CDN retrieves it from the origin server and stores it for future requests. Let's revisit our shopping application. Product images are viewed thousands of times every day. Without a CDN, every image request would reach the main server. With a CDN, images are delivered from nearby locations. This reduces server load and improves page load speed for customers around the world. CDNs provide several benefits: faster response times, reduced latency, lower bandwidth costs, better scalability, improved user experience. They also reduce pressure on backend servers because many requests are handled directly by the CDN. Architects ask a simple question: do users access static content frequently from different geographic locations? If the answer is yes, a CDN is usually recommended. Almost every modern public-facing application uses a CDN because performance directly impacts customer satisfaction. Let's summarize. A CDN stores copies of content closer to users. This reduces latency, improves performance, lowers server load, and creates a better user experience. Great architects know that faster applications often come from smarter content delivery, not just bigger servers. In our next video, we'll learn about WF, firewalls, and DDoS protection, and discover how architects protect applications from cyber attacks.